Hello everyone, my name is Avkash, and if you have Google account and access to just free version of Google Colab, you too can take advantage of very popular text to image generation AI models, and you can create beautiful synthetic images based on your own text input. This video is all about taking advantage of your Google Colab account and learn how you can use open source text to image AI models and generate your own images without need of any other resource. So before we start coding at Google Colab, I just have few more information to share with you. So most popular text to image generation model is OpenAI DALL-E and the DALL-E 2. They both models are available through invitation as well as using the OpenAI paid subscription model. Very recently, Google also shared their imaging model, which can also create synthetic images based on text input, and the results are very promising. Besides these two, there are some open source text to image generation AI models created by AI engineers worldwide. One is DALL-E, which is created by the Russian AI engineers. A couple of days back, I did create a YouTube video on that regard. Please have a look. And the second one is the DALL-E Mini and the DALL-E Mega, which is an open source variant of DALL-E. And these two models are available in public domain as open source. Today, we are going to use the DALL-E Mini and the DALL-E Mega models in Google Colab environment with just few lines of code. So let's get ourselves started. So today in this video, we are going to use the DALL-E Mini open source text to image generation AI model in the Google Colab environment with GPU enabled. Our objective is to follow this DALL-E Mini inference pipeline source code in the Google Colab environment and learn how the model is being downloaded from the weights and bias hub and use that model in the Google Colab environment and generate synthetic images based on our input text. To learn more about DALL-E Mini beyond this GitHub repo, you can also visit at DALL-E Mini card at Hugging Face, because both DALL-E Mini and the DALL-E Mega models are also hosted at Hugging Faces. So here I have the Jupyter Notebook open in my own Google Colab environment. Just to make sure I do have access to GPU, and at very first I would need to install the DALL-E Mini and the VQ-GAN JAX bindings. The next step for us to import the JAX library and make sure that we do have access to the GPU, and here we could make sure that we do have access to GPU available in this runtime environment. The next step for us is to load the DALL-E Mini related libraries. So we need DALL-E BART and the DALL-E BART processors from DALL-E Mini, and you can actually learn most of this code directly from this repo where most of the implementations are available. The next step for us to load the DALL-E Mini model. So here we need to provide the DALL-E model, which model we want, and if there is any revision we needed related with the DALL-E commit ID. So we need to define these two variables. So the DALL-E commit ID is not needed for us, so the value commit ID is none. And for the DALL-E Mini model, we need to define that we need the DALL-E Mini model. This could be the weight and bias artifact, or it could be the Hugging Face hub, or it can also be the local folder, or this location can also be the Google bucket. So let's set these variables, and now we could load the DALL-E Mini model. At this point, as you see that the artifact related with this DALL-E model is being downloaded in our local machine. If you want to learn where this model is available, you can actually look into the ls and look into the root, look into the hidden folder, and here you could see that the model is available in this cache folder. In cache, you can look into the weights and bias folder. Here you have artifacts, object, MD5, and here is your model. The way you could check the size of this model is that you could use du-sh, and you could see that this is about 1.7 gig model. So it means that model is downloaded in your local file system. In the next step, you want to load the VQ-GAN, and for VQ-GAN you also need the VQ-GAN commit ID as well as the VQ-GAN repo where it's going to be downloaded, and this model is going to be coming out from DALL-E Mini VQ-GAN ImageNet. So this is the repo, and the commit ID is going to be used to download the VQ-GAN, and that is about 290 meg. That model is also downloaded in our local file system. So at this point, both the DALL-E and the VQ-GAN models are downloaded in our local file system. Because we want the faster inference, so the model parameters are replicated on the devices. So the devices we have, the following code is going to take the request and parallelize it. So if you have the multiple GPU devices, you could take the advantage of parallelization. Because we only have one GPU in this machine, we may not be able to take advantage of it. The following code is going to generate the unique inference for per device. At this point, we are ready to start the DALL-E BART preprocessors. So here we are loading the DALL-E BART preprocessor. Again, you can take a look and you can get this DALL-E BART preprocessor, which is available in this processor file. So you could take a look the code implementation here. So now we have the preprocessor also available. Now we are going to create the prompt, and prompts can be multiple of them. So we can say prompts here, and prompts can be a collection of anything. So we could say, so that's the prompt we have. Let's start with this. We are going to tokenize our prompts. So tokenization is done. If we have multiple devices, then we need to replicate this code. So we could take advantage of all the GPU devices. And at this point, we are ready to generate the number of images based on our input. So here we are expecting to generate the 4 inputs. So 4 input, and here are some of the parameters, and the following code is what is going to be used to generate your image and render them outside. So I would say that this code is divided into 2 sections. First, these modules or the libraries functions are needed for us to generate, and second, here we are generating the images. So image generation is going to start. Here is our prompt, and we are generating 4 images. Here is an example of what we have generated. If we want to change the prompt, we could change here jungle, that's the prompt, and let's generate the images. And because we have GPU in this machine, we are getting the images faster. However, if you do not have GPU, just using CPU, just to generate these images is going to take about 8 to 10 minutes for you. So here you could see the bear image. The another very popular statement or the prompt has been used is that logo of an armchair in the shape of an avocado. So that's all you really need in order to generate your images. So you can see that just using the Google Colab with GPU enabled, we can take advantage of DALL-E Mini and generate whatever images based on our text input. The Jupyter Notebook, which we have covered in this tutorial, is available at this DALL-E Mini folder at the DeepWorks GitHub repo. That's all I had for you in this tutorial. I hope you have enjoyed the content in my video. If you have liked it, please do share it. Please subscribe my channel and also comment your feedback or any suggestions you have. I do appreciate your time and I'm looking forward to see you in my next video. Until then, please be good and do good. Thank you.